Thank you. Thank you, Joel, for all the Vancouver facts. I came here 3 weeks ago, 2 weeks ago for Open Source Summit. I fell in love with the city. And I feel like, well, maybe I should make plans to move here. But it's great. So today, I'm going to talk about Selftest. Kernel Selftest, I maintain Kernel Selftest. And I started 4 years ago. And I want to touch on what we have accomplished in the last 4 years, and then also go over facts, in terms of framework and briefly. And if I would like to leave some time for questions, if you have any. And okay, let's start. So first of all, what is Kselftest? It is a kernel regression testing tool for mainly started out, if you look at the Git logs and such, you'll see that the very first tests probably were, added back in 2005. You'll see it goes that far back. And then it is mainly started as a kernel developer regression test. That means that kernel developers write their own unit tests or functional tests, whatever they think. It is necessary for them to continue to find bugs, and then also when they add new features, they go and add new tests, so that we are not regressing anything mainly, and then also making sure that as releases come out, when we add new features, we are not regressing the existing ones. And it is also for kernel users. I often, even before I started Kernel Selftest, we are all used to running some sanity tests whenever we upgrade. So that's another thing for all users, even if they are not in any kind of kernel-related things that they do. Even casual users could run them to make sure everything is okay. I consider that to be a quick smoke test, meaning it can be used quickly to say, hey, how is everything working? It's not, I can't say that it's a complete test, obviously, because sometimes you will still find problems even if Kselftest passes. So, but it is a quick smoke test. But we are adding tests in such a good pace. Every release, we add 2 new target areas. When I say target areas, it's like, I'm not talking about individual tests in a MM space or networking space. It's more like new areas, like a C group tests that come in. And then also when sync framework moved from staging area, Android staging area into mainline, Gustavo Padawan added sync tests specifically for that framework to Kselftest. So we are doing a lot. Developers are very conscious of adding new tests. So what kind of tests do we have? I consider this a mix of white and black box tests. So since kernel developers write these tests, I consider them more white box because they know and understand the code. They are writing tests to tailor to that code. And there are some black box tests that users write. They both, as you know, all software engineers in this room know that they both have a value, because sometimes developers have blind spots, because when we write tests as a developer, we tend to write for we don't always consider all the things we might miss. So that's where the black box testing comes in. So I consider these as a mix of both. Maybe heavier on white box side than black box. They're both unit and functional. They will do unit testing. They go into a particular system call and different flags and test that. And then also functional testing in terms of C groups and is an example of functional test. And some are hardware dependent. I'll get into it a little bit more on hardware dependent tests. We do have a large number of hardware dependencies. I added a few when I was doing specific tests for a media hardware that I was working on. And then we also have stress and performance tests. RCU is somewhat of a stress test. We don't run them in default. And then also there are some performance tests in the mix. Performance tests could use improvement in terms of we also have the performance tool that we run. So that's kind of does a better job of in the kernel tools sources. So people use that more. So rationale for adding tests. So I'll go a little bit on how developers choose to add tests when they are writing. It's feature focused. That means, like as an example I mentioned, when both Sync framework and as developers or kernel developers are adding new features, they go and say, hey, we want to test this specifically. And then, so that is feature focused definitely. And then also bug fix focused. So in my case, I recently added a test for a driver that I found I did several security fixes, and I said, okay, I don't want I want to make sure those bugs don't crop up again. And then there is that kind of bug fix focused. And then there have been some tests, I think recently, we added x86 space for Spectre and the problems we recently fixed in the kernel. And they're almost always subsystem specific. That's how they are structured. I'll show you a graphic on how the hierarchy works. And what it's not for. It's not for testing specific workloads. Maybe C group might be a little bit of an exception, but if you configure it right, potentially, but in general, they are not for testing, say, hey, how, how this I/O heavy bandwidth is running or a CPU heavy workload runs. And also, it's not for testing specific applications. Like, for example, if you are going and trying to do audio application type testing or media space application testing, this is not for that. We don't have as many, and it's not a place either for that. So this is what I alluded to earlier. We have several targets. I think we have about like 46 or so right now, main targets. If you go into kernel Git, and then you will see, I call that a main target, right at the different, and then you'll see directory, net directory, x86 directory, and breakpoints. And those are all the main targets. Under that, we have several subdirectories in some cases. So subdirectories will focus on, for example, Android. Android has a Ion specific or Ion driver specific tests. And then they will have, as we add more tests in that space, we'll add more sub-tests, sub-targets. And then under each sub-test, we have individual tests. And in some cases, timers is a good example. I don't know if John is here. He has several tests. The way he did it, he has several timers. Under timers, he has test cases, individual test cases. So that's kind of, so when you look at targets and say, hey, only 46 tests, that's not quite true. We're running a lot of individual tests. So who are the authors? Mainly kernel developers, like I mentioned, and then also users. They come in and add tests, and I have had Kernel CI and Linaro, and they have been adding tests and changing framework, improving framework. And when Kernel CI and ARM, Kselftest started being used in ARM area, it has gone through tremendous improvements because none of the tests ran, even built on some ARM boards in most cases. So in the last 4 years, there has been a lot of activity in trying to get these tests to build and run on various ARM boards. So users, I mean, a lot of kernel developers, we run them. We might not run all of the tests. I mean, I run them. But if you take a x86 kernel developer or maintainer, they might just run x86 tests, or their focus will be. And then another example would be ftrace. They might go, maintainers of ftrace, they will run their tests. So, but kernel developers kind of run a slice of tests. So how do patches flow? I take patches directly, and then it is somewhat complex. It's because it's of the cross section of it spans the entire kernel. So when networking tests come in, they will have dependencies on the features that are going in the net tree. So what happens is I have an arrangement. I mean, we work together. Maintainers, I'll ask them, well, just take them through your tree, because it's too much coordination if I want to make sure I'm sending all the self-test passages. So that's how we work. So that's why you'll see a lot of self-test patches going through up to Linus's pull requests in networking pull requests, and then also MM and x86. And so that's kind of how we work. And then I take framework patches and any other patches. There are lots of patches that maintainers don't really have that much dependency on features. So all of those I take. So we work well together. I want to make it easy for tests to go in, as opposed to having roadblocks in getting tests in. So where are we using it? Currently, zero-day rings run it, is my understanding, and then definitely Linaro test farm. And the way I think Linaro test farm, Linaro developers, and they got involved about a year ago, and they provide great reporting. Stable releases come in, Greg sends them out, and then immediately I see reports coming in saying, hey, 51 self-tests passed, 1 failed, 1 skipped, So you're great with the reporting. And it's also run, my understanding, kernel CI rings, and that's where we are constantly improving a little bit, because we have to target certain configurations based on the board, based on what kind of kernel config options that we want to run and tests on that particular kernel that's built specifically for that board. So we are continuously improving that area. Ultimately, the idea is to be able to install self-tests and run them on all of the boards, as many boards as possible. So which releases are targeted? They get run on mainline, and then as our releases go from, Linus does his release cycles, RC1 through RC7 or 8, and then they also get run in stable releases. Stable releases is one that they get run quite extensively, because every week when the releases come in, reports come out with the releases. And also Linux Next. Linux Next is very useful to me. I think Linaro test farm does that. When I'm putting patches into Linux Next, if I know about any test failures, meaning tests failing, not bugs that are found in the kernel, but more like test starts to misbehave, or it doesn't build, or we have an opportunity to fix them before it gets into the RC1. Okay, so this is how many tests we added. I mean, the last 4 years, and I started maintaining this. Before this, we didn't have a tome Kselftest. I had the good fortune to name it Kselftest, and then back in 2014. Since then, 3.17 kernel. Now we are at 4.19. We have, in the last 4 years, we have added about We went from 16 targets to 45 targets. That's pretty good, 2 targets a release rate. So it's really good. I was doing the actual research for this presentation. I thought, wow, that's awesome. We are continuously adding tests. So that's what I like. I noticed that we not only are adding, as I mentioned, if you think about the graph I showed you, target and subtest and individual tests, there is a lot of tremendous growth in not only depth and breadth too, because we added a lot of targets and we keep adding new test cases and new tests under these targets. x86, MM, and networking, I have to say, are the most prolific. I mean, they just keep adding tests, which is great. Those are the core areas. Well, I mean, MM and networking are core areas, so I'm happy to have tests come in that area. And we have done lots of framework improvements. So we are looking at Kselftest framework. The components-wise, we have framework, common infrastructure. Common infrastructure meaning that if you have a new test added, you should be able to just hook it into the infrastructure and just run make from the main make directory. So that's really where the common infrastructure falls in. And we have individual tests. And framework supports a lot of common things, like, for example, interfaces to report results. Results is where framework, we have been making lots of improvements because we want to make sure that reporting is easier to understand and easier to detect run-to-run regressions. So, and then also when a particular configuration isn't supported, we want to report that as a skip as opposed to fail. And framework also supports API. And if an individual test calls into an API and says, hey, I want this particular, it failed, print a message, it will go ahead and print a common message that looks and feels the same as the rest of the tests. So what do you have more in common infrastructure? Building common infrastructure to build tests and actually running tests, and also reporting results. It also supports the script generation. In some cases, when install is done on a target, we want to be able to run the same script that gets run when you are running on the host. So there is a lot of common stuff that happens. And install tools come under framework and packaging tools. Packaging tools come into play when install tools, obviously, and packaging tools come into play if you are planning to run it on a different target than you're building on one system and taking it to. So what does default run? When you are running Kselftest default, what do you do? It runs non-destructive tests because we want this run to be a default run that, and then also there are a lot of tests that need to be run as root. So being a root gives you best coverage. I always recommend running mainline, taking RC, the current release running it on stables for best coverage. So use cases, you can run, obviously, on the same release, and then you can also run it on latest, and then install and run. So the 3 different use cases that we support. We have lots of stress tests that could change system state, so I recommend not running them. And if you are running them, user beware, they don't run in default anyway. And then we support test anything protocol for being able to simple text-based and parsing. It helps in parsing. External, we added that mainly to support external parsers detecting run-to-run regressions, and then also result parsing with external parsers. So I'll skip this, actually. You'll find the sources in the, and I maintain, it's a Linux Kselftest Git you can find. And there are documents right under the kernel source tree. And I also, once in a while, when there is something that happens, I add, write blogs on Samsung blog site. So my challenges, I am always trying to balance kernel developer needs and user requirements, user needs. There are different needs. Kernel developers want to run their own tests, being able to run them. Users want reporting in terms of they want to be able to pick out changes. And other challenges I face is balance kernel self-test default runtime with coverage. Because as we add tests, the runtime goes up. But we do also want to increase the coverage. So that's kind of what it is. So next steps, continue to increase coverage. And driver coverage is weak. I'm looking to see if we can add more tests there. And improving the framework. We're constantly improving the framework to aid mainly to run in kernel CI and Linaro test form runs and various test forms. And we are improving infrastructure as well as we go along. That's my slide with penguins. So keep the sweaters coming so we can keep it healthy. Thank you so much.
So we do have time for a question or two. Does anybody have a question? Anyone? Slow morning? Oh, Bill Mills.
You mentioned drivers, but aside from drivers, is there a particular subsystem that's on your hit list for you would like to see better coverage?
So we have, if there are any ARM-specific tests in terms of ARM64 or ARM, we have an x86 architecture, and PowerPC and x86 are well covered as an architecture test. I don't think we have very many for ARM, so that would be one area to add 64 and ARM. When we might have a common leverage between, MM and such cover both, for example. And then, so that would be one area I would say in addition to drivers that I feel like we could add more. Specific that are very specific to ARM and ARM64 as opposed to generic areas that cover.
So Shuah came all the way from Colorado to speak with us this morning, so please join me in thanking her again for coming.
Thank you.
Thank you so much.